Let's go ahead and go over how to evaluate functions when you're given a certain values for the input. So on this example, you can see what function notation looks like. So function notation is very similar to what linear equations look like. So it would be f of x equals mx plus b. And you can see that I label what each of those parts mean. So let's look at this example here. So we're given two different functions and we want to evaluate at those three different inputs. So what that means is that we're going to be inputting those three different x values into what our rule is in each of the functions. So for example, on A, our rule is -4 plus -x plus 4. So the left side is what your function is called. So on A is f of x, on B is t of x. And that's how you read it. So it's the letter and then of whatever's inside the parentheses. So since we have three different inputs, that means we're going to have three different answers for each of our functions. So this is how I like to set it up. All right, so let's go ahead and find out what f of -4 is. So notice how the inside of the function, the name of the function was x, but since we're replacing it with -4, all we're going to do is, in our rule, we're going to replace x with -4. So in other words, it's going to go into our rule and it's going to come out as another number. So that negative, whatever I replace, I want you guys to put it inside of parentheses. So we're going to distribute that negative to the inside of the parentheses. Since we have a double negative, it's going to become a +4. And then we just simply simplify. So f of -4 equals 8. So whenever -4 goes into our rule, an 8 comes out. And we're going to repeat the process for f of 0. So now 0 is going into my rule, and we're going to see what number comes out. So again, we would distribute the negative into the parentheses, but since 0 is neutral, it would just be 0 plus 4. Simplified, and we get that f of 0 equals 4. And we will repeat the process for f of 2, but we're going to do this mentally. You need to work it out, then you guys can do it on your paper. So f of 2 will be +2. So when 2 comes into our rule, 2 also comes out. So we have found our output for each of those input values, which is 8, 4, and 2. Now let's go ahead and repeat the process for our other rule, which is 6 plus 3x minus 2. So again, we're going to have three different columns since we have three different inputs. So we're going to get three different outputs. So let's go ahead and set it up. On here, there's three terms, but there's only one term that has x. So there's only one place in this equation that we're going to replace with -4. And again, every time I replace something, I always put the parentheses. So we're going to substitute for x, which is -4, since that's our input. Distribute the 4 to the inside of the parentheses. And 3 times -4, it's -12. We're going to simplify here. We get -6 minus 2, which is -8. So t of -4 is -8. When -4 goes into our rule, -8 comes out. We're going to do the same thing with 0 now. So 0 is going into our rule. Let's see what comes out. And some of these calculations you guys can do mentally, but if you need to show your work, then you go ahead and do the calculations on paper. But I'm going to do the rest of them mentally. And I encourage you guys to try this mentally, but you know yourself. If you need to do it on paper, then go ahead and do it on paper. So these are our 3 different input values when we have this input. So now you know how to evaluate functions when you're given a certain input values. And every time the input values are going to change, so they're not always -4, 0, and 2.